With our force versus time graph, at time equals 4 milliseconds, what is the force acting on the object? So we're going to look at 4 milliseconds and go up to see where it meets the graph, go across, and that looks like 500 newtons of force at 4 milliseconds. Over 8 seconds, what is the total change in momentum experienced by the object? Total change in momentum, or change in momentum, is equal to the impulse. Impulse is force times time, and our graph is a force and time graph. Here we're going to be looking at the area under the curve. Our graph is drawn as a triangle, so the area under the curve, the area being shaded in, is going to be calculated as the area of a triangle, 1/2 the base times the height. In this case, 1/2 times a base of 8 and a height of 500. When we calculate this, we get, should be 2,000 Newton, in this case milliseconds. And we know that our time is usually measured in seconds, so let's go ahead and convert it from 2,000 Newton milliseconds to 2 Newton seconds. Number 3, derive a formula to calculate the change in velocity. Keep in mind this says change in velocity, not change in momentum, but calculate the change in velocity of the object for that 0 to 8 milliseconds based on the change in momentum you calculated in 2, and m will be the mass of the object. So we've done the change in momentum, and we know the change in momentum is the impulse, and the impulse is mass times change in velocity, or delta V. For our number 2, we found that J impulse is 2 Newton seconds, and that's equal to mass times the change in velocity. So 2 is equal to m times delta V, divide the m over, and we get 2 over m is equal to delta V. Now we have a displacement versus time graph. With the displacement versus time graph, the slope is velocity. And we're looking for when it has a momentum of 0. When we have a momentum of 0, that's when we have a velocity of 0, because momentum is mass times velocity. So when do we have a velocity of 0? Well, that's when the slope is 0, because it is a displacement versus time graph. So that is from that 1 to 2 seconds. During what time interval does it have a positive momentum? Positive momentum would come from a positive velocity. So when does it have a positive slope? The slope is positive just from 0 to 1 second. And that's because this is a displacement graph. Keep in mind, that is why we're able to look at the slope. If the object has a mass of 50 kilograms, what is the momentum of the object from 2 to 3 seconds? Well, the momentum is mass times velocity. They gave us a mass of 50, and we need to determine what the velocity is from 2 to 3. So we're going to look at the slope from 2 to 3. Slope is delta y over delta x. And it looks like we're starting at 2 and going into -1, so we have a change in y of -3. And in the x, we're going from 2 to 3, so we have 1, so our slope is -3. If the mass is 50 and the slope is -3, the slope being velocity, momentum is mass times velocity, so 50 times -3. 50 times -3 would be -150. Then the units would be based on what we're using, the mass being kilograms, and then the velocity being meters per second, so kilograms meters per second, -150. Number 7, a kid is standing at the edge of a stationary floating raft in a pool. So the child is stationary, the raft is stationary. So they're not moving. The velocity is 0. Here it's asking about the velocity of center of mass if the kid were starting to move. Well, are there any external forces? If there are no external forces acting on the object, there are no unbalanced external forces, nothing's going to change in regards to the center of mass. So the velocity of center of mass remains zero. It remains stationary. Finally, a student says the center of mass of the kid raft system will not move when the kid walks to the other side of the raft. Do you agree? I absolutely agree. The child is moving to the right. The raft will actually float to the left because Newton's first law says that an object or a system that is at rest will remain at rest unless an unbalanced external force acts.